Hey guys, so I'm chilling out here in the back porch. It's a beautiful day outside. It's about 75 degrees. I got my coffee. I got my dog. Abby, say hi. Abby. There you go. And oh, there she goes. She's doing what she loves best. She's gonna chase after some squirrels or something like that. Yeah, you tell them, Abby. But you see, here's the thing. Abby loves to hang out here, and so do I. But we're not gonna be able to stay out here all year long. Why? Because we have seasons. And it's not going to be long before this whole back porch is covered with snow and it's going to be negative 20 degrees outside. And it's not really going to be a very inviting place for us to want to sit and chill. Question is why? Why do we have seasons? And that's what this video is going to cover. It's going to cover some of the basics about why we have seasons. So let's get into it. So in order for us to understand the seasons and why we have them, we first have to know where we get our energy from. And we take a look in the sky and we see that big bright thing there behind the clouds, and that's where we get our energy from. That's the sun. The sun produces the energy that travels through space through radiation, and that's why we call it incoming solar radiation. Radiation is just heat that travels through space and doesn't need to be connected to anything else. And we're going to define that word as insolation, not insulation. Insulation is the stuff that goes in the house and helps keep the house warm. Insolation, 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 that's the stuff that comes from the sun, or the heat that comes from the sun and helps keep the earth warm. And in order for us to understand why we have seasons, we need to understand that not every place on earth gets the same amount of insolation at one time. For example, right here in the summer, here in Chicago, we're getting more insolation, keeping us warmer, than somebody else that may be in the southern hemisphere, where they're getting less insolation or less direct solar radiation. So let's get into it. All right, so I set up a little model here to help us understand why we have seasons. I have a light that's going to represent the sun, or our incoming solar radiation, insolation. I have a model of the earth here. In fact, I have two. The first one's a flat earth on a paper plate, and the other one is a globe. These are both models of the earth. And what I'm going to do is I'm going to turn on the sun, or turn on the insolation. And the question is why do different places on Earth get different amounts of insolation? Well, if the Earth were flat, then everywhere on Earth would be getting the same amount of sunlight, same exact amount of insolation. Earth's not flat. The Earth is a sphere. And if we take a look at our spherical Earth here, what we can see is some parts in this globe are brighter than others. Now, I'm only talking about the part facing the light over here. The part facing away from the light, that's nighttime. But I'm talking about this part right here that's facing the light directly. And what we have is we have a spot right here that's brighter on the globe than spots up here. Why? Because the insolation is striking the Earth right here more directly. Now, what do you think that means for temperature? And then down here, you'll see that it's also a little bit darker. Again, if the Earth were flat like this, everywhere on Earth would be receiving the same amount of incoming solar radiation, or insolation. But because our Earth is spherical, it's curved, we have places on Earth that are receiving different amounts of insolation throughout the day. But the question is why does it change? Why do the seasons change throughout the year? We just said that some places on Earth receive more insolation than others, or more direct sunlight than others, which would certainly affect the temperature on the daily basis. But why does that change throughout the year? Let's get into the rest of it. So in order for us to understand seasons a little bit better, we're going to set up another model here, this little demonstration. We call this the light board demonstration. And what we have is we have a light right here in the middle that's going to represent our sun, or our incoming solar radiation. And then we have 4 thermometers all set around the sun at different angles. We have one that's flat, we have one that's at 45 degrees, one that's at about 60 degrees, and another one that's facing dead on at 90 degrees. And what I'm going to do is I'm going to turn this light on. It's pretty bright. And all these thermometers are all set away from the light at an equal distance, so they're not closer or further away. And I'm going to turn this light on, and we're going to see which one heats up the most. Now, as I do this, I want you to make a quick prediction. Which one do you think will heat up the most? Is it going to be the one that's flat? The one that's about halfway up at 45 degrees? The one that's about 2/3 of the way standing up at about 60 degrees? Or the one that's standing straight up at 90 degrees? Make a prediction about which one do you think will get the hottest. We'll come back in just a minute after these have had a chance to heat up. All right, so these have been heating up for about 5 minutes or so, and what I'm gonna use is I'm gonna use this little temperature gun, and what we're gonna do is figure out the temperature of each one of these 4 thermometers. And again, the question is which one's gonna be the hottest? Is it gonna be the one that's laying down, the one that's at about 45 or about halfway up, the one that's standing straight up at 90, or maybe the one about 2/3 up at about 60 degrees? Now to do this, again, I'm gonna use this temperature gun because these thermometers can be hard to read, so let's go ahead and take a look. All right, here's a little bit of a different look at the board. I have all the thermometers laid out just as they were. Lights still on. I have thermometer A, B, C, and D. Let's go ahead and take a look at those temperatures. I'm just gonna hit the gun here. And for the one that's standing straight up, we are at 108. And then we're gonna go ahead and move to the one that's about 45 degrees up. That's thermometer B. I'm gonna try to hit it in the same spot. We have 97.6. I'm gonna move over here. Now I'm going to hit the thermometer C. That's the one that's laying down flat. And that is at 97. And then I'm going to hit thermometer D right over here. Try to hit it in the bottom, just like the others. And that's 98.7. All right, well, that's pretty clear that the thermometer that is standing straight up, this one right here, that had the highest temperature. And the thermometer that's laying straight down, that had the lowest temperature. And then in order, the higher the angle, the higher the temperature. So if we take a look, thermometer D had a higher angle than thermometer B, and thermometer D produced a higher temperature than thermometer B. So I know this can get confusing, so let's go ahead and talk about it real quick. The flat one was the coldest. The flat one was the coldest. Thermometer B was a little bit warmer, and the angle increased a little bit. Thermometer D was warmer than that, and the angle increased again. But then thermometer A was the hottest, and that one is standing straight up. Now, why is thermometer A hotter? Why is thermometer C the coldest? It all has to do with the angle that the light is hitting these thermometers. Thermometer A is receiving more direct light. Thermometer C is laying down flat, and it's receiving less direct light. And thermometers B and D are right in between. And that's why their temperatures changed as well. And when we talk about this angle of sunlight or angle of light hitting these thermometers, that has a dramatic effect on our seasons.